So let's suppose that you're going to drive to a friend's house, and you live here, and your friend lives here. And let's say that there's one road that connects your house to your friend's house. And let's say that this part of the road measures 3 kilometers, and this part will measure 4 kilometers. The question is, how far is your friend's house from your house? Now, some students who incidentally might be majoring in philosophy may say, well, what exactly do you mean by how far? And that would actually be a very good question indeed. You see, there might be two perspectives in which we could frame the question of how far your friend's house is from your house. Maybe by how far we mean, how far would you have to drive to get to your friend's house? And if that's what we mean by how far, well then it seems fairly straightforward. You must drive this distance of 3 kilometers, and then drive this distance of 4 kilometers, and thus you would have covered 7 kilometers in total. However, if by far we mean, how far is the straight line length between your house and your friend's house, well then obviously 7 would not be the answer. How do you think we can find the straight line length between your house and your friend's house? Well, what do we know? We know this length here is 3 kilometers, and this length here is 4 kilometers. And we're looking to find this length. Wait a minute. No. Is that a right triangle? I think it is. That looks like a right triangle to me. Awesome, right? Why is this awesome? Because we can actually solve this now. Remember, it appears that we need to find the length of the hypotenuse of this right triangle. So how do we find the hypotenuse when we know two sides? Yep, Pythagorean theorem. The good old a squared plus b squared equals c squared. Now remember, c represents the hypotenuse and a and b represent the two remaining sides of the right triangle. So we simply need to plug in 3 for, let's say, a, and then 4 for b, and then all we need to do is solve for c. So let's do it. Right, first we square both the 3 and the 4 separately, and then we'll add them together, which totals 25. Next, we will square root both sides to get rid of the square on c, because we need to find c and not c squared. And lo and behold, we arrive at an answer of 5. This means that the straight line length between your house and your friend's house is 5 kilometers. So let's take a step back. We found that you would have covered 7 kilometers if you measure the amount of ground your car had to travel to get from your house to your friend's house. And we found that the straight line length between your house and your friend's house is 5 kilometers. So which is the right answer to the question of how far? Well, again, it depends on how you frame the question. If the question asked, what is the distance between your house and your friend's house? Well, then the correct answer would have been 7 kilometers. But if the question asked, what is the displacement between your house and your friend's house? Well, then the answer would have been 5 kilometers. And this is the conceptual difference between distance and displacement. We can consider distance to be the actual amount of ground covered from the start point to the end point. And you can think of this as what your car odometer would read. Whereas we can consider displacement to be the straight line length from the start point to the end point. Now, it's very important that you define the start point and the end point of a question. And as both the distance and displacement are relative to these 2 points. And depending upon how the start point and end point is defined, will determine how you go about calculating distance and displacement. For example, the question we just looked at defined the start point as your house and the end point as your friend's house. In other words, you can pretend that you traveled to your friend's house and stayed there forever and never left. Right? That was the end of the problem. And you can see that the yellow ball covered an actual distance of 7 kilometers, and the straight line length between the start point in yellow and the end point in yellow is 5 kilometers. Now, pretend I changed the question. Well, actually, don't pretend since I'm actually doing it. Let's say that the question now asks you to calculate the distance and displacement if you start your trip from your house, you visit your friend's house, and then on your way back home you stop and grab a slice of pizza. So let's start with the distance. What is the actual amount of ground the yellow ball covered in going from your house to your friend's house and then to the pizza parlor? Yes, it was 11 kilometers, right? Here, check it again. 3 kilometers plus 4 kilometers plus another 4 kilometers is 11 kilometers. Now, what is the displacement? In other words, what is the straight line length from the start point to the end point? Focus on the yellow dots. Yes, it's 3 kilometers. Now, there's one more thing about displacement. Displacement also takes into account the direction of motion. And check out our next video for a thorough lesson on that topic. And I'll leave you with this question. I want you to think about it. Then check the comments below for the answer. What is the total distance and total displacement for your entire trip? If you were to leave your house, then visit your friend's house, then grab a slice of pizza, and then return back home. Consider the definitions of distance and displacement carefully. And guys, I thank you very much for tuning in, taking the time to watch our video. We appreciate it very much. If you could do us a little favor by hitting that subscribe button and also telling your peeps, we would be forever in your debt. And we thank you so very much.